So we broke down radicals, we've multiplied them, we've added them. We are going to divide some today. So remember, to be completely simplified, you can't have a radical in the denominator of a fraction. So when we had square roots, we multiplied by one additional factor inside of our square root, top and bottom, so we could break it down. Now if I've got a cube root here, to have a perfect cube, I need 3 factors multiplied times itself. So if I have 1 right now, I need 2 more inside of my cube root to have a perfect cube. So I'm going to multiply by the fancy version of 1, that is cube root of 2 times 2 over cube root of 2 times 2. Which, reminder, the only reason I can do that is because that really is equal to 1 and it doesn't change the value of my expression. So when I multiply, I got 3 times the cube root of, I went ahead and did 2 times 2 is 4. And then on the bottom, third root of our 3 factors of 2 that we needed. So it's just 3 times the cube root of 4 over 2. Part B is pretty similar. So I would go ahead and break that up into separate numerator and denominator. So like cube root of 2 over cube root of 5. I erased it because it looked like a whole number 3 instead of an index on my radical. Now remember that it is a cube root, so I'm going to need, since I have 1 factor of 5 right now, I'm going to need 2 more factors of 5 before I can take my cube root. So why don't you pause it and try it and then check back and see if we match. All right, so multiplying by those 2 additional factors of 5 inside my radical is going to give me the third root of 2 times 5 on top and the third root of 3 factors of 5 on bottom. So on top, I'm just going to go ahead and multiply that, since nothing breaks down, into just 50. And then the bottom is 5. So it's the cube root of 50 over 5. And the 5 on the bottom is outside the radical. The 50 on the top is inside, so I can't reduce or divide out any common factors. So I believe we did some of these when we first talked about square roots, but remember that you need to multiply by the conjugate of your denominator, because that's the only way that you are going to end up with radicals with opposite signs that subtract off to 0 when you multiply these 2 binomials together. So if you multiply 2 times everything that's on top there, you're going to have 2 minus 2 square roots of 3. And then in my denominator, 1 times 1 is going to give me 1, and then 1 times negative square root 3 is negative square root 3. Square root 3 times 1 is positive square root 3. And square root 3 times negative square root 3 is going to be just, if you want to go ahead and make it negative 3, no radical, you can. So if I combine, I'm going to have 0 square roots of 3, which was our goal. And then 1 minus 3 is going to give me negative 2. I have a common factor between all of those terms, so I could go ahead and divide everything by negative 2 and just end up with 2 divided by negative 2 is negative 1, plus, since you have negative 2 divided by negative 2, 1 square root 3. Let's talk about a couple more variables. So I'm going to go ahead and simplify inside my radical by dividing out a common factor of x first. I tend to find that that makes this easier. And then I'm going to look at the square root of 2 over the square root of xy and think about, okay, this is just a square root, so I need 2 factors of each of those variables. So I have 1 of each right now. Let's multiply by 1 more of each, which will give me the square root of x times y, or x squared and y squared in the denominator, which you can then actually take the square root of and just have xy. On E, I'm going to break it up into, again, top and bottom of my fractions separately inside of my cube root. And then the cube root of x to the 4th, you could start by bringing out an x, but I actually think it's easier if you just think about, I have 1 complete group of 3 factors of x's right now. How many more do I need to complete a second group? Well, I need 2 more factors of x to complete a second complete group of 3. So I'm going to multiply by those 2 additional factors of x that I need inside my cube root. And then that's going to give me the cube root of y to the 6th x squared over the cube root of x to the 6th. And then that it just gives me x squared. And on top, I have y squared times the cube root of x squared. Now we're going to solve some equations. So pay attention to the directions. We're supposed to give exact answers in these problems. So reminder, when we did like x squared equals 25, we took the square root of both sides to undo our second power. So here we're going to take the fourth root of both sides because we have x to the fourth and I just want to get x. So breaking down my 32 is going to give me 5 factors of 2. So it's a fourth root. So I can do the fourth root of 2 to the fourth and still have 1 factor of 2 left over inside. And it is an even root, like square roots were plus or minus. A fourth root, sixth root, all those you're going to have positive and negative, because if you take a negative times itself an even number of times, you still get back to your original value. On B, the only thing that's cubed is x, so I want to go ahead and get x cubed by itself first by dividing by 6 before I take my cube root. So if I divide by 6, I'm going to get x cubed equals negative 64. Take the third root of both sides and can break down negative 64 into, I'm just going to go straight to 3 factors of negative 4. So you'll end up with just x equals negative 4. Now that was a odd root, third root, fifth root, all those are just going to match the sign as the original number. So it was a negative, so we're going to have cube root of negative 64 equals negative 4. We're now going to approximate some. So here, the entire quantity x minus 8 is raised to the 6th power. So I'm going to go ahead and undo that first by taking the 6th root. To do the 6th root of 100 in your calculator, you can hit 6 and then a second and then the little x radical, depending on what calculator you have. That should get you positive and negative. Remember, it's 6 roots an even root, 2.15 approximately. And then you'll have to add 8 to get x by itself. Since it's 8 plus 2.15 and 8 minus 2.15, you're going to end up with 2 different solutions, approximately 10.15 and 5.85. On B, only x is being raised to the 6th power, so we need to get x to the 6th by itself before I do my 6th root. So I'm going to first subtract 2 and then divide both sides by negative 7. So I'll have x to the 6th equals positive 31, and then I'll do the 6th root of both sides in my calculator. Since I'm rounding to the nearest hundredth, it's going to be approximately positive and negative 1.77. All right, one last one that we're going to do here, your favorite word problem. So we're looking for a final speed that we have to reach in order to survive outrunning some velociraptors. So if you look at this equation, it's what equation calculates your acceleration, and you're given your acceleration as 4 meters per second squared that you need to reach. You also know that you need to accomplish that for 5 seconds. So in your equation, t is going to be 5. We're starting from standing still, so my initial speed, v sub I, is going to be 0. If I plug all of that in, my equation's going to look like 4 equals my final velocity squared minus my initial velocity, which was 0, squared, over 2 times my 5 seconds. And then I can just solve that for my final velocity that I need to reach. So I have that final velocity squared over 10. Multiply both sides times 10, and I get 40 equals my final velocity squared. Take the square root of both sides, and remember that although this technically gives you positive and negative, you are going to want the positive 6.32 meters per second.